All right, so now we're going to do Unit 3, Objective 3, writing equations of the polynomial function. Okay, now we need to focus on those important things that we learned from Objective 2, x-intercepts, y-intercepts, multiplicity. We need to focus on all those things we learned on the previous objectives, so we'll be able to write an equation for the polynomial. Okay, there's a difference between writing equations. When we write the equations for a polynomial function, it has to look up this form right here. F of x equals a, that's our leading coefficient that we always wanted to find out, the leading coefficient, times quantity of x minus b, b represents a number, and times the quantity of x minus c, c represents another number, dot means that can be more factors. So this is the general form of a function that we want to write for polynomial functions. And we need to focus on the little a. So for solving for a, we will solve for a if we're solving for the equation. So if the problem is asking us write the equation for the polynomial, then we have to solve for a. So we'll solve for a if it is the equation, okay? So that's because it's a unique equation, okay? It's a unique solution for that piece of information that's given. Now, we're going to leave the a in the equation when solving for an equation, okay? So we're going to pretty much leave the a alone. If they ask us to solve for an equation, that's because we're just writing a general solution, okay? A general equation for the set of information that's given, okay? So the values of b and c are the x-intercepts of the function. So I have to know the x-intercepts. That's the values of b and c right here. They're value numbers on the x-axis. They're x-intercepts. Okay? All right. So I will mention this information as we're solving. I'll keep referring back to it so we understand these definitions and information right here. Okay? So here's the step-by-step instructions. Steps to write an equation. So this one is for an equation. Example number 1 says write an equation. So we are not asking for the equation. It's an equation for the graph below. So here's the information. It says list the x-intercepts and the multiplicity. Let's do that very first step right there. So when I look at the graph, I see that it is crossing at the number 2, and it is bouncing right here at 0. So why don't we write that? Let's write x equals 0. There's right there. That's one of the x-intercept. And x equals 2. There's the other x-intercept. I wrote exactly where it touches the x-axis. It says if the x-intercept is a bounce, which it happened right here at 0, then the multiplicity is 2. Okay, so let's write multiplicity 2 because we bounced. If the x-intercept passes through, the graph passes through the number 2, then the multiplicity is 1. So we write multiplicity 1. Okay, so that's step number 1, check. Now it says set up the equation. Okay, f of x equals a times the quantity of x minus b times the quantity of x minus c, if we have more factors. Because I only have 2 factors, I'm only going to set up 2 parentheses. Okay, so here we go. F of x equals a, x minus something, that's my b value. Another one, x minus something, that's my c value. It says, remember what we said just right here about b and c? Let's go back over here. The values of b and c are the x-intercepts or the zeros. Okay, x-intercepts and zeros means the same thing. So they're the x-intercepts or zeros of the function. So I'm going to write this value that I found right here, 0. That's what I'm going to put right here, 0. And then a positive 2. This minus is part of my equation, okay? So I'm going to put the number 2 right here, the positive 2. I know it looks negative. The reason why it looks negative is because the minus is part of my equation, okay? So there we go. So I set up the equation. Now, if the multiplicity is 2, bounces, then the factor has to be written as x minus b squared, okay? So because it bounced, the multiplicity 2, then I have to put a squared on this one that has the 0. So I have to put a square right here. Go back over here. If the multiplicity is 1, if the answer only appeared once, multiplicity 1, then it passed through, then the factor is just x minus b. So I don't need to put a exponent. The exponent is the invisible. This multiplicity 1, you can imagine as an invisible right here. You don't need to write it. So there we go. So now let's clean up a little bit, okay? We can do a little bit of cleaning up because honestly, x minus 0 is just x, okay? Just like 5 minus 0 is just 5. Anything minus 0 is just that number. So why don't we clean up a little bit? We write f of x equals a, that's the leading coefficient. X minus 0 is just an x, but it still needs to be squared because of the multiplicity 2. And then the parenthesis x minus a 2. So there we go. Determine if you need to solve for a. Well, it's an equation, so no. Okay, it's an equation, so I am done. Just determine the sign if it's positive or negative. Okay, now we need to determine, is it a positive a or a negative a? This is super important right here. Okay, we have to determine, do I do a positive a or a negative a? Well, we started up high in the positive infinity. Let's look at the end behavior we learned in objective 1. We read a graph from left to right. Okay, just like we read English. Okay, so I started on positive infinity, and then I went down to negative infinity. So my leading coefficient has to be negative for you to start from high and end low. So the a value has to be negative a. Okay? So if I'm going to write it again, f of x equals negative a times x squared times the quantity of x minus 2. That would be our final answer. And I don't need to solve for the value of a, the leading coefficient, because you're just asking me for an equation right here. I just determine if it's positive or negative according to our graph. Okay? So that is how you do it, following the instructions. There's a reason why these instructions are here on the side. Sometimes I kind of like break the rules and I go a little bit out of order, but just follow the instructions carefully. Okay? Let's do it one more time. Let's write an equation because problem B is under the example 1, so we're still doing an equation. All right? So first says list the x-intercepts and the multiplicity. So let's go ahead and list it. I see it right here, a negative 1, so x equals negative 1. Because it bounced, we're going to write multiplicity 2. Okay, and then that's a y-intercept right here, but we don't know the value of it, so we're going to leave it alone. And then it touches right here at x equals 1. It crosses, okay? It crosses right through, so we're going to put multiplicity 1. And then x equals 2. It also crossed through it, so we're going to put multiplicity 1. So we have 1, 2, 3. We have 3 factors. Okay, we have 3 x-intercepts. We have 3 values. Because we have 3 values, we're going to set 3 parentheses. So here we go. F of x equals a. I'm going to put x minus, that's 1 parenthesis, x minus, that's the second one, and x minus, that's the third one. So we set up 3 parentheses with our general form. Okay. I'm going to bring the negative 1. That's my very first one. I'm going to bring a negative 1 right there. I'm going to bring a positive 1 right here. And I'm going to bring a positive 2 right here. I write exactly what I see. A negative 1, a positive 1, and a positive 2. Okay? Let's take care of the multiplicity. Multiplicity 2. That tells me I have to put a squared on this negative 1. Multiplicity 1, I leave it alone. There's an invisible 1. And multiplicity 1, there's an invisible 1. Okay? Let's clean it up nice and neat. Okay? Because those positives, we have to take care of this negative times this negative over here. Okay? So a negative times a negative becomes positive 1 squared. And over here is just an x minus a 1, and over here is just an x minus a 2. So there we go. We took care of things very carefully. If you notice, the negative 1 became positive, the positive 1 became negative, the positive 2 became negative because of the change of signs. Now, the last thing that tells me to do here is to determine if I have to do my positive a or negative a. Well, it's an even function going both the left going down to negative infinity and on the right going down. So that tells me that is an even function. Yes, it is even, but it tells me that the leading coefficient is negative. Okay? So we need to make that little a negative. I'll do it one more time. F of x equals negative a times x plus 1 squared times x minus 1 times x minus 2. And there is our final answer. It's a general equation for that graph. Okay? If we wanted to know specific what the a value is, you have to give me one more piece of information, right? So the graph has to give me something extra. So that's how you do an equation. All right? Okay, so let's practice the equation. All right? Let's practice the equation. Here we go. So write the equation. That means is a unique solution for this graph, okay, for the polynomial. So pretty much the step says write an equation as before. Okay, so I just follow the same exact steps as I was doing before. So let's do that step number 1 right here. Let's do exactly what we were doing before. So let's go ahead and mark the x-intercepts. There's 1 right there at negative 3, and we crossed it. There's a negative 1 with a bounce, and there is a positive 1 with the cross. So let's go ahead and list them. X equals negative 3. There's one of the intercepts right here, and we crossed it. Because we crossed it is multiplicity 1. And then we have x equals, this one is negative 1. Because we bounced is multiplicity 2. And then there's this other one right here, which is x equals positive 1, and is multiplicity 1 because we crossed. Okay? So I have 3 x-intercepts. 1, 2, 3. Okay? So let's go ahead and write an equation. All right? So f of x equals the a value. Then I have 3 parentheses, x minus, another one x minus, and another one x minus. Okay? All right, so I have 3 parentheses. Let's go ahead and bring the values exactly the way we see it. A negative 3 right here, a negative 1 right here, and a positive 1 right here. So we take care of the signs. A negative times a negative. This is going to become positive 3. Okay? A negative times a negative is going to become positive 1. And a negative times a positive stays negative. So there we go. We have an equation. Because our function on the left is going up to positive infinity, on the right is going up to positive infinity, then our a is positive. So there we go. We took care of it. The a is positive. Our leading coefficient is positive. I brought the negative 3 became a positive 3. The negative 1 became a positive 1. The positive 1 became a negative 1. Now let's not forget the multiplicity according to the factor. The negative 3 has multiplicity 1, so we leave it alone. The negative 1, when we brought it, became positive 1. It has multiplicity 2. So we need to put the multiplicity here, squared. And the x plus 1, the x equals 1 became a negative 1, multiplicity 1, we leave it alone. So that's the work, but that's for an equation as before. To solve for a, we're going to find and label a point on the graph. If an extra point is not given, not the x-intercept, okay? So what he's saying over here is that we have to find and label another point on the graph, okay? If not given, we can find another one, but it cannot be an x-intercept. So if not given, we can use a y-intercept, okay? If it has to be obvious for us to count. So the y-intercept over here is not obvious, but they gave us an extra point, okay? So I'm going to use the extra point. I'm going to give more room on my paper here, okay? So here we go. I have this extra point on the graph, which is -2, -1. That's my extra point. There's a reason why they gave us the extra point. The -2 is our x value. The -1 is our y value, is x, y. Okay? I'm going to go ahead and replace everywhere I see the x's with a -2. And everywhere I see a y with a -1. Well, I only see y one time. Okay? F of x is the same as y equals a times x plus 3 times x plus 1 squared times x minus 1. So I just rewrote the equation, the function f of x, I replaced with the y. I'm going to replace the y, this y right here, with the number -1 equals a times, every time I see an x, we're going to replace with a -2. So -2 plus 3, and then we do -2 plus 1 squared, and then we do, -2 minus a 1. So there we go. I replace the x's with -2, I replace the y with the -1. Now let's work carefully, okay? PEMDAS, we take care of parentheses first. PEMDAS. Parentheses first. So -1 equals a. So a -2 plus a 3 is a number 1. A -2 plus a 1 is a -1 squared. A -2 with a -1 becomes -3. Okay, now I took care of the parentheses. Now let's take care of the exponent. -1 equals a 1 times. -1 squared is just a +1 because it's -1 times itself twice, times the -3. There we go. Now that we're going to do multiplication, we're going to multiply these values together. -1 equals a. 1 times 1 times -3. 1 times 1 is 1, times -3 is -3. Now we divide both sides by -3, and we get the answer. A equals a negative divided by a negative becomes 1/3. Lots of extra work to find that A value of 1/3. Okay? So now that I know what A is, I can come over here and write my equation. F of x equals +1/3 times x plus 3 times the quantity of x plus 1 squared times the quantity of x minus 1. And that is our final answer. Okay? Solving for the A value. There has to be either an extra point given to us, or if the extra point is not given, we can use the y-intercept. Okay? So I will help you set this up, but I would like for you to do it by yourself. Okay? Notice that there is a y-intercept over here at -1, and there is a bounce at +1. So x equals -1, we crossed it, so multiplicity 1, and x equals a +1, but there's a multiplicity of 2, so we bounce it. They did not give us an extra point, however, they gave us the y-intercept. Why don't we write that? It's 0 for x, 2 for y. That's going to be our extra point, okay? So I would like for you to set up your equation. F of x equals a times x minus and x minus. Pay attention to the bouncing, bringing the -1 here, bringing the +1 here, the multiplicity, and solve for a with your extra point, which happens to be the y-intercept 0, 2. I would love for you to try this. See if you can solve for the a value and write your final equation. Bring it to me in class. During our class time, we're going to go over this question to make sure you got it right. And then we can go over questions, okay? All right. Now let's go over one more example if they give us a set of information in a different form. So, example 3. Sketch the polynomial function containing the given points and then write the equation. So I have to solve for a. When you ask me for the equation, that means I have to solve for a. Okay? So they ask us to sketch the polynomial first with whatever's given to us. You probably are not familiar with the word quartic. Okay? I'm not going to give it away yet. I want you to figure it out what quartic means in just a minute. Okay? Let's go ahead and use this piece of information. These are order pairs. Okay? An order pair is given in the form of x comma y. So they gave us order pairs, x's and y's. If you struggle with this, seeing a bunch of zeros and stuff, why don't you label them x and y, x and y, x and y, x and y for every single one of them, okay? Why don't you label them? All right, so I'm going to draw a little sketch right here to the best of my ability. X is -5, so -1, -2, -3, -4, -5. And the y is 0, so that means it's right here, is an x-intercept. Okay, the next one is -1, 0. -1 is right here, 0 is right here. -1, 0, that's another x-intercept. Then I have a 0 for x, 12 for y. Well, then I'm going to put it right here, 12 for the y, because that's my y-axis. Okay, so that is a y-intercept. And then I have a 2, 0. 1, 2. Only label the tally marks that shows our x-intercepts. Then I have a 6, 0. 2, 3, 4, 5, and 6. All right? So we just follow along the x's and the y's. There we go. So it's interesting. What kind of shape could this possibly be? Okay? Just, I'm going to see lightly here with the pencil. Just play with it. How about if I started from the bottom here? If I crossed, 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 and crossed. Almost. Okay, what did I miss? I missed the y-intercept. My y-intercept is not down here. My y-intercept is it's up there. So why don't I flip it? Okay? How about I start from high, cross, cross, go touch the y-intercept, cross here, and cross here. There we go. Let me erase this extra markings that I did lightly before. Okay? So we were just guessing. We're just playing with it. Okay? Just using a little bit of critical thinking, like what kind of graph do we have? Okay? So that's kind of what we have right there. Let me do it with the pencil again. Started from the high, cross here, touch the y-intercept, 2, and 6. Okay? I did it wrong at first, and then I did it the right. I figured out how to do it the right way. So what kind of function is this? This is an even. Okay? So an even function. So what do you think quartic even with the idea of even number would be? So if you guessed number 4, then you're correct. It's a quartic is a 4th power, right? It's a 4th power. All right? So the degree should be 4. Well, let's find out if we're right. Can we write an equation here? Okay, we have all the x-intercepts, just like we were doing a minute ago. So let's write x equals -5. It crossed, so it's multiplicity 1. X equals -1. It crossed, so it's multiplicity 1. X equals 2. It crossed, so it's multiplicity 1. X equals 6. across, so it's multiplicity 1. I have 4 x-intercepts, 4 of them. None of them bounced. So I have 4 parentheses. F of x equals a. X minus 4 times. X minus and x minus. We're going to bring them, okay? That negative 5 is going to come here and it's going to become positive 5. The negative 1 is going to come over here, is going to make it a positive 1. That positive 2 is going to come over here and is going to make it negative 2. That positive 6 is going to come over here, is going to make it a negative 6. They're all multiplicity 1s. There were no bounces, so there's no squared values here. All right? Now I would like for you to solve for a. I want you to use the y-intercept of 0, 12, right there, okay? I would like to challenge you for you to use the y-intercept and replace the x's with zeros, the y with the 12, and solve and write the correct equation right here at the end for me so we can compare in class, okay? And then I want you to try this other one, the cubic, okay? That's for you to do right here. A cubic means power of 3, right? It's a 3. The power is 3. It's a cubic one, odd power, so you can solve it as well. Do the same exact thing I just showed you. Go ahead and write your x-intercepts, your y-intercepts, and see if you can solve it, okay? I would love to go over this with you when we're together in class. Okay, so writing the equation, it's done. Good luck on objective 3.